Welcome to this explainer. Today we're unpacking a massive paradox. How did a geographically small island, one with pretty limited natural resources, become the absolute center of the modern global economy? Think about it. On a standard world map, Taiwan doesn't exactly jump out at you. It's got a population smaller than a lot of major metropolitan areas. And yet it literally holds the keys to the technologies that run our entire modern world.
It's a genuine mystery when you look at the raw facts. Taiwan spans just under 400 kilometers from north to south. You won't find vast oil fields or massive rare metal deposits there. By traditional geographic measures, it's not a geopolitical giant, but its importance to your daily life and the global economy as a whole absolutely cannot be overstated. So how does a place with so few natural resources become so uniquely vital? Well, the answer isn't geography. It's silicon.
To wrap our heads around exactly why it's so vital, we just have to imagine what would happen if that silicon suddenly stopped flowing. If Taiwan were to disappear from the global supply chain tomorrow, the immediate consequences would trigger a catastrophic domino effect across almost every major industry. Factories all over the world would immediately slow down. Automakers wouldn't be able to build new vehicles. Those highly anticipated smartphone launches, delayed indefinitely. Multi-billion-dollar artificial intelligence projects would literally grind to a halt. We're talking severe, immediate shocks to healthcare, aerospace, telecommunications, you name it. Everything is connected, and the linchpin holding it all together is Taiwan.
Section 1. The Pure Play Revolution, from agriculture to advanced tech.
Okay, so let's dive into how Taiwan actually pulled this off, because this unprecedented position definitely didn't happen overnight. For a big chunk of its history, the island's economy relied heavily on agriculture and textiles, not the ultra-advanced manufacturing we see today. But following some really strategic, export-oriented investments in education and infrastructure back in the mid-20th century, Taiwan intentionally pivoted. By the 1970s and 80s, rather than just competing on cheap labor, they shifted their entire focus toward engineering expertise and high-value tech. And this all culminated in a massive turning point in 1987, when an engineer named Morris Chang founded TSMC. That's the Taiwan Semiconductor Manufacturing Company, with a totally unconventional business model that would, eventually, change the world.
This perfectly illustrates the paradigm shift Chang introduced. See, under the traditional semiconductor model, a company had to design and manufacture their own chips, which meant if you had a brilliant idea for a new chip, you also had to somehow find billions of dollars to build a factory just to make it. Talk about a massive barrier to entry, right? But Chang introduced what's called the pure play foundry model. Basically, TSMC offered to strictly manufacture chips for other companies, absolutely refusing to compete against them on the design side. They took on the huge financial risk of building the factories, so their clients didn't have to.
This specialization unlocked global innovation on a scale the world had literally never seen. Since designers no longer needed to spend tens of billions of dollars on fabrication plants, they were suddenly free to focus entirely on architecture, software, and just pushing the boundaries of technology. Companies like NVIDIA, AMD, Qualcomm, and countless hungry startups were freed up to just dream and design, while TSMC focused relentlessly on becoming the absolute best in the world at manufacturing.
Section 2. The Master of Complexity. Why money can't buy chip supremacy.
Let's zoom into the microscopic level for a second to really grasp the manufacturing moat TSMC built over the decades. We are talking about what is arguably the most demanding industrial process ever developed by humankind. To understand the sheer, mind-boggling scale of this complexity, just consider this number: tens of billions. A single advanced chip today contains tens of billions of microscopic transistors packed onto a surface no bigger than your thumbnail. It's wild. Producing these requires an extraordinary level of precision. They're created in manufacturing plants known as fabs, where the air is kept up to 10,000 times cleaner than the air outside. Why? Because a single, invisible speck of dust can ruin an entire batch of wafers worth millions of dollars.
And that microscopic complexity? Well, it's mirrored by a massive macroeconomic cost. Tens of billions of transistors, yes, but also tens of billions of dollars. Building just one of these advanced fabrication facilities takes years of intense construction and costs an absolute fortune. The machines inside performed thousands of individual manufacturing steps, with engineers monitoring temperature, vibration, and chemical purity down to the literal atomic level.
So the crucial takeaway here is that money alone cannot buy success in this industry. Even if you somehow have $40 billion lying around to build a fab, you still need incredibly high production yields. That's the percentage of chips emerging from the line that actually function correctly.
Achieving high production yields requires decades of operational experience, accumulated knowledge, and continuous, daily refinement. That kind of deeply ingrained expertise is just something you simply cannot purchase overnight, no matter how deep your pockets are.
Section 3. Powering the AI boom. The hardware behind the algorithms.
This mastery over manufacturing feeds directly into the modern artificial intelligence revolution. Because honestly, without TSMC, the AI boom as we know it simply wouldn't exist. Training advanced AI models requires a truly staggering amount of computing power. We are talking about processors capable of handling trillions of mathematical operations in the blink of an eye. For the world's most advanced chips, the hardware powering the AI algorithms designed by heavyweights like NVIDIA, TSMC is the overwhelmingly preferred manufacturer. The massive data centers, the powerful AI accelerators, the billions in government AI investments, almost all of that unprecedented demand flows directly through Taiwan's semiconductor ecosystem.
Section 4. The Silicon Shield. Geopolitics and global supply chains.
Zooming back out to the global stage, this intense concentration of advanced manufacturing has birthed a really fascinating dynamic that experts are studying closely. It's the intersection of economics and global supply chains, bringing us to a concept a lot of analysts call the Silicon Shield. Basically, this is the idea that because the entire modern digital economy flows right through this small island, it creates massive economic incentives for the international community to support regional stability. The world is so severely dependent on Taiwan's semiconductor production that any disruption would have devastating worldwide consequences. Now, while experts definitely debate how this concept would hold up in a practical crisis, the underlying economic reality of the world's reliance on Taiwan is completely undisputed.
And we actually got a glimpse of that vulnerability recently, after global chip shortages ground auto and tech production to a screeching halt a few years ago. Panicked governments worldwide realized something crucial: semiconductors are foundational infrastructure. So the United States passed major legislation to encourage new domestic chip investments. The European Union introduced its own massive semiconductor programs. Japan and South Korea expanded their support. Heck, even TSMC itself has begun diversifying, building new fabs in the US and Japan. The world is desperately trying to rebuild its supply chain resilience.
But there is a massive catch here. Building a fabrication facility is relatively easy if you have the money. Recreating an intricate, highly specialized ecosystem, that is nearly impossible. Taiwan's ecosystem isn't just the fab itself, it's a dense, interconnected network. You have highly skilled engineers, specialized suppliers, advanced equipment giants like ASML who make the ridiculously complex laser machines that actually print the chips, chemical producers, highly efficient logistics networks, and most importantly, decades of hands-on operational experience. You just cannot copy and paste an ecosystem that took 40 years to organically grow.
Which really brings us to the core truth of this entire fascinating story. Taiwan has become indispensable not because it consumes the world's most advanced technology, but because it enables the world to build it. History usually remembers the inventors, sure, but Taiwan's true historical legacy is that it serves as the ultimate enabler. It is, quite literally, the factory behind the future.
So I want to leave you with this thought as we wrap up this explainer. As we look ahead to a future utterly defined by artificial intelligence, quantum computing, advanced robotics, and next-generation communications, we have to ask ourselves, how will the world navigate its ever-deepening dependence on the extraordinary capabilities of this one, small, indispensable island? The technology of tomorrow is being forged right now, and the entire globe is relying on Taiwan to build it. Thanks for exploring this with me today, and keep asking the big questions.